days are like that, you know?
Yep.
Would have sworn we had this whole other computing thing working out. You want to just stay up here? It's Parma, right?
It's Param.
Param.
Yep.
Param, you're awesome. Meet my new best friend, Param.
Hey.
You guys are late. We're gonna hope that this works, and in case it doesn't, my new best friend Param is gonna help me, and he's like my IT person on the stage. My name is Eve Mailer, and I'm with ForgeRock, and I think I might have the longest title in this entire conference. So thanks for being willing to stick it out with that entire beginning moment of panic while we got the slides to hopefully work. And we're going to be talking about actually applying access control techniques coming from all over, most especially from the web, to hard problems of privacy and security in the Internet of Things space. Now hopefully, I've got all kinds of things coming up on the screen, but this works. All right, so this is how I want to tackle this subject. Now, we've got a double length session here, which is just 50 minutes. I hope to actually leave time for questions, and I am happy to have this be interactive. So the way I want to approach this is to examine the challenges we have, look at the problem space, and then test out the authorization-related solutions that we have lying around in the web technology space. And then introduce to you a technology that I work on called User-Managed Access, or UMA, and then take a look at how it measures up to the requirements. Thank you. And then conclude and take a look at how it measures up. But first, I want to just say a word or two about who the heck I am and why I'm here talking about this. I actually come from, I'm going to put this down here or just wander around. I come from the digital identity world, and I actually come from a long line of folks who have worked on empowering individuals and people who create content in a lot of ways. So as you saw on the first screen, my Twitter handle is actually XML Girl. So I'm one of the folks who co-invented XML. Oh my God, Parm. This is going to be, why is it doing that? What's
I don't know. Keynote is dying.
Oh,
so.
Keynote. Yeah, wait, is this in Keynote?
No.
Oh, yeah, Excel's dying.
Excel is dying too, though.
Note to self, don't use Excel. So I started out working on technologies that are about information modeling to let people take control of their own data, wresting it away from those who were controlling it in the form of word processing. And I moved into the realm of digital identity and controlling your own personal data, which gets us into the topics of privacy, and I would argue into the topics of controlling access to data that's about you and data that you create. And that's how I come to this subject here today as we move into the Internet of Things era. So we actually find that extra constrained environments versus the web environments that are not particularly constrained from our perspective present really super duper authorization challenges. So as you saw in this wonderful dishwasher picture, you know, when you can imagine internet connecting anything, well, why not internet connect a dishwasher if it can help you do things like save money on your hot water expenses, if it can have you run dishwasher cycles at opportune times. But by the way, you're exposing information to others, perhaps in the cloud services that are managing those things. When you do dishes, when you have company over, when you're not at home, when you're canning vegetables, things you may not have thought about. In the process of managing all of those pieces of information, and maybe who even gets access to your dishwasher, if you have people coming into your home to help you clean it, or if you have guests in your home, you have to manage things like the household automation aspects of the groups of things in your home, the guilds, as some people call them, of the things in your home. You also have to manage the groups of people who interact with those devices. So those are some of the implications of the internet-connected dishwasher use case. Another thing that we need to think about is smart medical thingies. So in this picture, we might have a smart stethoscope. We might also have a smart lab coat. those two things might now need to interact. And oh, by the way, a doctor might be checking the heartbeat of a patient. So now you have two people, two thingies, several cloud services, upstream data, downstream data, a complex permissioning environment. So those are some of the things you have to start to think about that maybe you didn't think about when it was old-fashioned web services or modern APIs. And my most favorite example of all, solar freaking roadways. Is there anyone here who hasn't seen that YouTube video? Maybe this is getting old, long in the tooth now, but if you haven't seen it, you got to go to YouTube and just search for solar freaking roadways. These are the hexagonal, tempered glass topped, internet connected, solar power collecting roadway toppings that you can assemble into driveways, roadways, recreational park toppings, whatever it is. And you can imagine actually a lot of security downsides. You know, if you can stripe the roadway dynamically, if there's, you know, a moose on it so that you can route around it, you can imagine somebody sending you off a cliff. You can also imagine interesting authorization things that you can do once you have a smart roadway. Did you think about that? Huh? Well, that's all I think about. So these are use cases that waken us to the possibilities of new things we have to solve. So with these use cases, I want to present you with some high-level requirements that we have to solve for in this world, in this new world of authorization. What are the requirements? Well, for one, obviously, we have a requirement of scale. All right, maybe we can't get to, what was it, 50 trillion, maybe it's 25 trillion if we can't scale to showing a display off of a laptop in 2014 in Moscone Center. But clearly, it's not just number of devices, number of relationships between devices, it's also number of people. So, you know, we just mentioned a lot of things and they start to have interactions with each other. So it's the relationships between those things that have to start to scale, and those things are not really linear. Another requirement that we have is the notion of discovery, particularly dynamic discovery. So this is one of these smart city pictures. So if you have smart cars and smart bikes and smart civic things, then oftentimes those are going to be things that have a transient relationship with the citizens and the residents that they interact with. And so you actually need a quite dynamic notion of onboarding and offboarding in the relationship with people and things, and people and people and things and things. So transient to permanent becomes a continuum that you have to become much, much more comfortable with. I mean, if you're familiar with so many of the enterprise IT architectures of the present and the past, lots and lots of times we design these lovely dynamic solutions. Uh-oh. Wake up, please. Yeah. We have these lovely dynamic solutions, and then they tend not to get used. We're much more comfortable with static onboarding of things because they're just easier. So I submit to you that we're going to have to get comfortable with dynamism and transience in a way we never have had to before. So that's a requirement of the future. A third requirement we have is privacy like we've never seen it before. I have this lovely picture here, which I think is the back end of a Lamborghini, because exhaust data is something we talk about in the world of personally identifiable information. Let's say that you internet connect your dog by virtue of putting a chip in your dog. And you take your dog out for a walk every day because it's useful to you to track your dog's movements. Oh, please don't go away. You're now trackable. Did you think about that? It's not at all clear. Oh, please come back. It's not at all clear that we all think at all times about exactly what it is that counts as data about us when we're interacting with all these things. You know, there's consumerized versions of Internet of Things. You know, everybody understands when you talk about a Nest device that it's tracking, you know, what temperature you like and when you're going away. But you have to have another level of subtlety about privacy to realize that a driver of a fleet vehicle is an individual person who, you know, they may be doing work for hire, But the work that they do is being tracked, and they have rights too. In fact, in a lot of countries, those rights are explicitly captured in regulations. So privacy gets new subtlety and poignancy in this kind of environment. Flexibility is a fourth requirement. What do I mean by flexibility? I have no idea why the screen just went off there. I just touched it. It's going off and on at will.
I have no idea.
At this point, it's a mystery, so we're just going to proceed. It'll just flash. Who knows why? Yeah, it's probably the connector. So at this point, I'll just do dramatic readings of what I think is going to be on the screen next. So flexibility, what do I mean by flexibility? Fine grain of access. You know, I was just talking to a fellow who works on connected car dongles that you can attach and that you can use to perhaps permission your son or daughter to drive your car under limited circumstances. We talk about, in the realm of API security, the valet key that only lets somebody do something limited and scoped versus something else. Well, it may literally be, or a lot closer to a valet key, when you let them drive the car but not get into the trunk. Okay? That is a kind of flexibility and granularity. And oh, by the way, you're talking about two people in that circumstance, not just one person using all the apps in question. A fifth requirement is what you can call partitioning. Now, this is a picture that actually comes from a group at the Internet Engineering Task Force, the IETF, called ACE, which stands for Authentication and Authorization for Constrained Environments. And they have a nice document that they call ACE Actors. And what they've figured out is, on the right side, you've got a resource owner who has some sort of resource server, and they mean that to apply to maybe a device, maybe with an associated cloud service, and it may be very constrained, but then there's a kind of gateway level in the middle, and then there may be somebody on the left, a client owner, maybe an app that wants to get access, and that client owner, I don't know, has similarly a need to get access. So it's kind of client server, but it's also kind of reflecting constrained environments and reflecting that you can have fewer constraints as you go up. And at the top, you have the people. So this partitioning is really interesting because it reflects that you've got not just clients and servers, but you've kind of got client people and server people of data, which is really interesting. And I want to point out an implicit requirement that these people have sort of baked into their thinking, which is they've kind of baked in that you have to have a continuum between web and Internet of Things thinking in the solutions that you need to come up with. Because if you only solve for one and not the other, you've built something that's not applicable to the real world. So I think in a very real sense, the web of things is a very important solution space. Certainly, that scalability thing applies to IoT in a pure sense in a way that it doesn't apply to, you know, your average RESTful API, perhaps. But I think that this partitioning picture and the recognition of this ACE group shows that web of things is a phenomenon that we can't ignore. So if we take that set of requirements as a really good high-level set of requirements, maybe not everything in the universe, but relevant to our authorization query, where can we go with this? How are we doing there?
You can just say next slide.
Oh, next slide. Thank you, Param. So with those in mind, I have to remember what the next slide was. I think I do. I think what I was going to do was say, hey, all right, well, let's look at existing web authorization technologies and see how they do. So this is a build. Who's here familiar with XACML, the authorization, yeah, the Extensible Access Control Markup Language? I know that guy is. So we've got this picture on the right that shows what I think of as the P*P architecture for XACML. Now this came about in the web services era, and it's pretty well ensconced in enterprise IT thinking, I would say. And the main piece that's really of interest is you've got a policy decision point that hands out permit-deny decisions to a policy enforcement point, which protects the resources of interest. And then the policy enforcement point can let the application, that would be the client, in or not. Now, it turns out that in a lot of ways, this is sort of too stiff and too brittle a particular arrangement of architectural components. There's a nice piece of XACML that I love, which is that it ensconces portable declarative policy. But it's got this policy decision-making protocol piece that we can look at to see if it satisfies IoT authorization needs. And I would submit to you that it turns out from experience that one of the things it doesn't do is scale nicely. Next slide, please. Another thing that it turns out not to do is to support discovery nicely. And the reason that it doesn't is that the typical way that XACML is deployed is there's kind of a single majestic policy decision point. Like a typical deployer of an XACML system is like the US Department of Defense. And it has the PDP, and the policy enforcement points around it are onboarded in a fairly static fashion. You got to go back. Sorry, I don't know where. There, yeah. We'll just go straight to that one, and that was a build, and we can just go to that. Thanks. All of my clever telegraphing is not going to work. That's great. Thanks. I'll just talk to it. So discovery actually doesn't really work with XACML too well, so that doesn't help us too much. Privacy, there's actually a privacy profile for XACML, so you can make policies that have the effect of protecting some privacy, so that's kind of a question mark. I would say it's kind of one foot in, one foot out. In terms of flexibility, I'm sorry to say it turns out that deployment-wise it doesn't actually meet our needs. And partitioning, it actually has, you can see it's got a lot of piece parts there. P star P, policy information point, policy administration point. One thing it doesn't have is the notion of a person who can serve as a resource owner in an explicit fashion. So what I mean by that is an explicit partitioning of a recognition that there may be people on each end of this. So that's something that it turns out is very useful in an IoT context, as we see when we talk about, wow, we've got a connected car thingy. We've got smart medical thingies. We need that. So if we say, OK, XACML is not going to actually take us all the way. What can we look at next as a technology? We'll go to the next slide, please. And we look at OAuth 2. Who here is familiar with OAuth 2? You guys know the flows, about half and half, maybe. So what you see here is the canonical architectural diagram of OAuth. And a lot of people have probably experienced OAuth and the classic OAuth flow, maybe without knowing what it is. If you've ever maybe gone to a news website and wanted to comment by putting a comment on an article, and it says log in through Facebook to comment or Twitter to comment, and it sends you to Facebook or Twitter to log in and consent, and it brings you back. That's kind of what's happening. So that news site is a client to, say, Twitter, and Twitter functions as the resource server and also the authorization server collecting your consent and then sending back an access token so the client can then proceed on a limited basis. So OAuth has some nice properties, actually, collects consent, and it also lets you can log into Twitter and say, I'm not happy with Twitter and New York Times having a relationship about me and exchanging information about me. I'm going to go revoke it, and you can do that. And that's kind of powerful. But that's runtime consent, and being tempted to click that I agree button is a fairly weak notion of privacy. So the way I would assess OAuth is, in terms of scale, we see that things like Twitter and things like Google and things like Facebook have extensive ecosystems of client apps. So I'm going to give them, maybe 1 point out of 2 for scale. I think that we're learning how to do that. In terms of discovery, there's actually a spec that's starting to be used around dynamic client credentialing so that you can give apps their own unique credentials in interacting with these systems. So we'll give it 1 point out of 2. The third requirement was, I don't remember. Privacy. So privacy, I think I gave it 1 point out of 2 because it's got that consent at runtime is weak. Revocation, whenever you feel like it, is strong. That's an interesting kind of mix. I'm going on by memory here. I'm going to look at my screen. Flexibility, actually, because we see that it's got this notion of scope and grain, you can actually have a notion of the access token that the client app gets. We talked about how it may be limited in terms of what it can do. It may get view access, but not write access to the API, and that's known as scoping in OAuth. So we're going to say, yeah, it's got that grain that we're looking for. That's enough flexibility. Partitioning, we're going to give it the 1 point out of 2 because it's got a resource owner that's meant to be a person. That's actually a step up in the world of authorization and privacy. That was actually a major innovation that OAuth came up with. And in fact, I would point out to you, it's actually ironic that Facebook, of all companies, ensconced the user as an intermediary in the flow of their own personal data as the thing that's going to have to say, I consent. Facebook, of all companies, made that pattern a thing. And I think we're all better for that. So OAuth is kind of like, okay, it gets us part of the way there. That's interesting. So in light of that, he's got like a crystal ball, and he's like,
This is the bizarrest thing I've ever seen.
I know. It's amazing that you're doing this. I don't know if you drink, but like whatever you drink, I'm going to buy it for you. Please
Very expensive proposition. But
Oh, I know some good places around here. All right. Next slide, please. So let's talk a little bit about how we share data, which is what we're talking about, how we choose to share data without a formal authorization solution in the middle. One build, please. It's either filling it in by hand and by value, ick, inaccurate, annoying, or we have these secret URL things like on YouTube where it gets emailed out and it's just a link like any other link. That's not very secure, so we can't use that. Or I happen to go to the Fidelity site, fidelity.com, if you want to see how you import Fidelity data when you're doing TurboTax, when you're doing your tax returns. It scrapes your username and password, saves it, vaults it, and then replays it into the Fidelity site. Yeah, that's wrong. It's not only wrong, but as soon as we start getting stronger auth that no longer uses passwords, biometrics, wearables like the NIMI band that uses your electrocardiogram to authenticate by, guess what no longer works anymore? Password vaulting. So we actually need a delegated, constrained authorization solution that meets all of these requirements. So next slide, please. With those things in mind, I actually want to introduce you to the thing that's called User-Managed Access. The reason we have that picture is that's Alice and that's Bob. Next slide, please. Assuming it'll go.
Just thinking about it.
Okay. Yeah, we don't know.
There we go.
Overshoot. So UMA in a nutshell, we do pronounce it UMA like the actress or like the goddess. It's a draft standard. It is actually built on top of OAuth 2. If you want to, you can actually think of it as a set of standardized APIs for authorization, privacy, and consent. And they're RESTful APIs. They work with HTTP. The work is being done in something called the Kantara Initiative, which specializes in high-quality identity. I happen to be the founder, the chair, and what we call the chief humanitarian of the group. It's currently in last call, and we're planning to actually head to a finalized version 1.0 in Q1 of next year. And it's currently in interop testing in its v0.9 state. So that's just kind of the version in one slide. What you see here is the architectural diagram for UMA, the marvelous spiral of UMA. So what's interesting about this is that if you notice all these piece parts in here, they mostly actually replicate the OAuth piece parts, and all the names are the same. And we see here that we've got Alice and we've got Bob. And we've got use cases that we're solving. You guys are such troopers. I'm going to buy you all a drink after this. What do you say? Come on, let's go. So if you want to share stuff, just not with everybody. If you want to share it selectively, whether it's with an app that you use, or whether it's with your friends and family, or whether it's with your employer, or whether it's with your dentist, that needs to be possible. Next build, please. On the other hand, there's a lot of folks who are not part of the TMI generation, and they say, look, I don't want to engage unless I can protect it, and I know it's going to be okay. Next build. And the last use case that we want to treat is, look, I want to proactively control the data that's about me, and maybe even the content that I create. And I just don't want to feel like I have to consent and hit that I agree button like I'm a rat at a feeder bar to get anything done. Those are the use cases. This PBD thing, by the way, just real quick, sorry. Privacy by design. Anyone familiar with this privacy by design initiative? It was started by Ann Cavoukian, who until recently was the Information and Privacy Commissioner of Ontario. And there's 7 principles. I happen to be a privacy by design ambassador. And so some of the principles have to do with things like building in privacy, not bolting it on. So you can sort of imagine where that goes. Next slide, please. So under the hood, it in fact just builds upon OAuth. So you can think of it as OAuth++, one more build. So you, anticipate. 5 points to the person who knows the reference. Thank you. All right, so 2 things to note about what it adds. You saved me. Resource server and authorization server were 2 things that we saw in the OAuth picture. In OAuth, there's no official arrows that go between them, so there's no standardized protocol between them. UMA actually loosely couples them because it's interesting to be able to have an authorization server that floats with respect to one or many resource servers. So if you think of maybe many companies that do different jobs, whether it's a fitness wearable company, or whether it's a smart stethoscope company, or whether it's a smart refrigerator company, they all may have data that somebody wants to use and recombine in some fashion, but they're run by different companies. And the same person who might use all of those services may want to centrally manage the sharing of that data. That's where it's valuable to loosely couple those 2, because they may be run by different companies. I know. And then the second big difference is that in OAuth, it turns out that, I know, it's amazing. It turns out that OAuth has no Bob. OAuth has no requesting party separate from the resource owner. Who here uses Twitter? I'm using Twitter, a fair number of folks. All right, I hope we'll all connect on Twitter, XML girl. Hope to meet you on Twitter later. So I use Tweetbot on my phone. So like the example of, I download Tweetbot from the App Store. The way that I connect Tweetbot to the Twitter API is, I basically log into Tweetbot through Twitter. That's the whole being redirected over to login and consent and come back. It's all me. So that's why we call it Alice to Alice sharing. I'm not sharing my Twitter data with anybody else but me. Alice to Bob sharing is more like what you do with Google Docs when you create a document and you share it with somebody else for the purpose of collaboration or whatever. So the entire notion of a requesting party doesn't share credentials with Alice. That's new to UMA. Yeah?
In your model, do you imagine a universal authorization server or multiple ones, or does it matter?
It's centralizable. There are lots of different ecosystems that you can imagine. So if you use the example of Google, actually, I mean, they've built something that's proprietary to them. So essentially, they've got their own central one, but it's a closed system. Right. If you look at how social login works, where Google and Facebook and Twitter, those are all their own things, but they're kind of pretty central because you find a lot of folks accept them. So they're fairly wide ecosystem. One of the pieces of work that I'm doing now is actually working on patient-centric healthcare data sharing. And they're working on a pretty wide ecosystem for that. The question would be, well, who would be the central authorization servers? And my surmise is that it might be the electronic health record vendors, like the SaaS app vendors. So in that case, it might be fairly wide, but you still might have the notion of, oh, what if I want data portability because I want to use a different new authorization server? That's always a possibility. And in fact, I think it's a human right that you may want to switch. Even if you started with A, you may want to switch to B. So a few quick thoughts on that. Yeah? Mm-hmm.
Why did you say central? Because inherently it has to be distributed, right? Some roles may be proxy functions. And that way you have your identity validated wherever you created it.
Mm-hmm.
But the other intermediaries
So, sure, validating identity is something that should be done at every authoritative identity provider, but we're talking about authorization, not identity here, not pure authentication. I know. You're being so patient.
Meditation practice.
Yeah. Zen. So in fact, there's value in centralizing. If you think about, well, I'll give you an example in a second. Let me think.
Why you can't federate?
Well, in fact, it is. I mean, it is federated. So what we're doing by it's funny. Do I say federated? Do I say centralized? Or do I say distributed? Because like I can sort of make a case for saying any one of those three. And actually, let me do this slide next because I think that'll help. So what I'm really talking about is authorization as a service. So go with me on this journey, if you will. So you've got a resource server that what it wants to do is outsource protection to an authoritative authorization server. So one more build. So that authoritative authorization server exposes APIs that helps the resource server do that job. Now, look at the equivalence. The resource server is akin to a single sign-on relying party. So we've been starting to think of this terminology of like AZRP, if you're familiar with federated identity patterns. And the next build, if you will, the authorization server is kind of like an authorization provider, so akin to an IDP. So by breaking apart what OAuth glommed together, it's RS and AS, by enabling them to have arrows between them, effectively, we've made authorization federatable, if that makes sense. And turns out there's super duper use cases for it, even in the enterprise, even if it's not Alice, but it's actually an enterprise that wants to centralize its business logic, for the same reason that an enterprise wants to be an IDP for its employees. And so far, all I'm talking about really so far in describing UMA is really web use cases. We'll get to a more IoT use case in just a moment. So what could policies that Alice might want to create look like? Do you still have Excel running? What
I
do you?
have no idea. I think what's happened is it doesn't have web connectivity. So it's trying to go and get network access and then dying.
I see.
And I can't even see that screen. Is that okay?
It's, no, Excel quit unexpectedly.
Yeah. All right. That makes resolve this.
Okay.
Yeah.
Never been
I
so
hope it
glad to
does.
see a quit unexpectedly in my life.
Yeah.
All right, so what are some policies that might actually be interesting to set? Think of them as sharing settings. Number one, only let my tax preparer with this email address using this particular client app access this bank account data, so think of that as an API endpoint, if they've authenticated strongly and not after tax season is over. Those are some interesting bounds on authorized access. Next one, please. Let my health aggregation app, my doctor's office client app, that's often an EHR SaaS system, and the client for my husband's employer's insurance plan, which by the way covers me, which is why I care, get access to my Wi-Fi enabled Scale API and my fitness wearable API to read the results they generate, but not post data, although posting data would be kind of cool in the case of the Scale. Just saying. Finally, because I couldn't resist, when a person driving a vehicle with an unknown ID comes into contact with my solar freaking driveway, alert me and require my access approval or the gate doesn't go up. These are totally within the realm of the possible. These are tractable, these are not futuristic, these are doable. If the thing has an API, the simplifying assumption here is it's got to expose an API, which, as we've seen from the web of things, they do. Okay. So now a lot of people will ask me, all right, but isn't the user experience going to really suck? I mean, people don't know how to deal with policies and privacy is hard and. What I will say is we do it all the time. The picture there, I mean, you don't even have to see this picture because who doesn't use Google Apps? I actually asked this question last, all right, who do you work for?
Myself.
Oh, okay. I asked this question last night, and the one guy who raised his hand was the Microsoft guy. And I said, you know, who doesn't use Office 365? It turns out he didn't use Office 365 either. But we do it all the time, and I'll tell you why I'm convinced, first of all, that it's not a problem. It's a particular kind of privacy we get when we control who we're sharing with and why, because we already know why we want to share it. When you create a document, for example, you create it, you have in mind who you want to share it with and why. It's, you know, in healthcare, they talk about a lot of meaningful use standards, and someone has to ask you for and tell you why they want it, and you have to consent to it, and there's a whole bunch of kind of rigmarole for consent around privacy because they're asking you and you have to consent. But in fact, when you proactively choose and set a policy, you know why. When it's authorization, it's a kind of privacy that's really different, and you have your own motivations, and you're motivated to set it however you wish because it's self-generated. And we've got examples of pretty good user interfaces for it. But you can make them even better because once you have the use cases in mind, you can build in system default privacy policies. You can build in, well, when it's a client app that I myself am operating and an ID token comes in that identifies that it's me again, let it happen. Don't even ask me for consent at runtime. You can make things invisible that way. So I'm pretty convinced that I'm not really worried about the UX. I think we need this. Okay. I think, yeah, I'm going to run out of time to go through the gory details of the UMA architecture. There's a lot of information online. I haven't put the tiny URL for UMA, but I'll give it to you just verbally here. tinyurl.com/UMAWG. But I do want to walk through a fitness wearable use case so you can sort of map the UMA concepts to the IoT use case. So if you want to think of applying UMA to a fitness wearable use case, the device user is the resource owner. We've been talking about the resource owner, Alice. She has discretionary resource access control rights, and that means that she's got those proactive privacy capabilities through being able to configure her authorization server to bring the boom down on Bob or whoever wants to get access. The device and the cloud service that go together constitute the resource server, and they're likely to communicate however they want internally, likely through one of the constrained protocols. We actually don't have to care for UMA purposes, as long as what they expose outward is UMA. We're near the end. One more. Yeah, I know it's waiting. When you think in these ways, here's some benefits that you get. You get flexibility in binding an individual to a device and the corresponding service because the Alice resource server, authorization server tuple, the triad, is represented actually with an OAuth token that lets the resource server use the API at the AS on Alice's behalf. It's just an OAuth relationship like any other OAuth relationship internally. That's how UMA protects its own APIs. It can be revoked. It can be reset up with somebody else. So it can be transient when you need it to be. Next one, please. Flexibility and centralization when possible in letting an individual choose sharing settings and even revoke sharing. This is critical, actually, for the notion of not just the transients, but for true privacy. Comprehensive yet simple platform approach to device service protection and access control. We've been talking, in ForgeRock to a number of parties who are keen to maybe start with a closed ecosystem, but quickly grow it to an open ecosystem so that they and their partners can write to standard security and authorization APIs. This enables that.
I think it needs to be open from the get-go. I don't think it should start closed.
Well, yeah.
You're bringing in all the other stakeholders that have a say.
Right.
Because if you start off with a closed session, eventually people are going to start with for-profit already.
Right. All I mean by that is just, you have most favored nation partners when you're in beta, and then, you're basically, yeah. Yeah. Fair enough. Well, then in that case, start open, start radically open, and, you want to have security APIs that, I think anymore, if your core competency is in the platform that does fitness, frankly, your core competency is not in the security and authorization of that. That's why OAuth exists, in fact. I mean, that was one of the most fascinating things about OAuth's creation. Yahoo and AOL and, a bunch of folks, Google, all looked at each other and said, well, our core competency is doing what we do. And turns out we have these security mechanisms that look kind of like each other. Let's get together and commoditize them, codify current practice, so that we can get on with the business of value-add APIs that we can charge for, right? So, not to put too fine a point on it, that's one of the lovely things I actually think about OAuth, and I hope about UMA as well, is like, access control is about security, but it's also about monetization. You can't charge for a resource unless you can throttle access to it, and the thing I'm most excited about is Alice can now get into the game as well. I mean, she could actually demand a receipt for Bitcoin for getting access to her fitness data, if somebody's trying to do longitudinal studies on health. So I have this concept mappings. I'll make these slides available on SlideShare, and you can study this at your leisure. But what I've tried to do here, since it's a little bit unfair since I didn't go through all the UMA architectural details with you, what I've done is on the left, I've got generic concepts, and on the right, how we map them to UMA. So what you're seeing is an UMA resource owner would be the device user. The device and service together would be the resource server. So what you see typically now is you've got a device certificate in a secure element. And what you ideally want to do is use that as a strong form of OAuth client credentials that drive that Alice resource server authorization server tuple, that OAuth connection that they have, that permissions the authorization server to do its job. This is something that we've been working on actually in ForgeRock, and it works really nicely with our identity stack. My colleague Victor talked about that earlier today. It's something that actually just comes naturally as breathing to us, but it sounds like it's not actually so easy for some folks. So if you're interested in that, you should come talk to us. So you can take a look at that mapping at your leisure, but to conclude, or maybe to sum up, hopefully it's just thinking. Scenario domains run the gamut. I've been actually use case hunting lately, and every week I go and talk to a different set of folks, whether it's telco or higher ed or healthcare or IoT or a bunch of things. And so on the right, you see channels that it's applicable to you. And again, I would say you cannot preference one of those channels over another. If it doesn't apply to API, web, mobile, and IoT, I think we've failed. What about what?
M2M.
I see, pure M2M to me is like IoT 1.0. And I'll get to a moment to a comment about kind of pure M2M in the sense of sort of pre-internet or disconnected mode. I have some thoughts on that. So I don't know if it's going to the next one. Yeah. So if you actually compare the UMA spiral diagram, I was so excited when I saw this ACE actors diagram because, in fact, the UMA spiral goes directly to it. So I think it actually answers the need pretty well. Next slide, please. So how does it do against all of these? And you could just build it out. What I would say, and I'm biased, as you now know, I would say that scale, it just hasn't proven itself out yet. We don't know, so I'm going to give it 1 point out of 2, but I think that it's got some nice properties. But I think that it's proving itself pretty nicely in all those other categories. And I actually haven't seen something competing that makes as good a run at these requirements. So final comments. I'll spend a moment on each of these bullets. So if you go to the UMA wiki at Kantara Initiative, you'll find that there's a bunch of case studies that have been submitted, including an industrial IoT one, and I'm working on a healthcare, more consumer-facing one. There are some enterprise API use cases, which we've barely talked about, that have actually been deployed in production by some of the folks who are on the working group. There's a bunch of open source available to play with, more as expected. I've been working with Intel. They've done an experimental industrial IoT implementation. They're the ones who wrote this refrigerated shipping container use case that we put up. They did that in Node.js. I mentioned that V1 of the protocol is slated to be sort of wrapped up in Q1 of next year. And the most interesting one, to your point, is there's some future work that can be done. There's a number of extensibility points in the protocol and in the various, like the tokens that you can be profiled. One of the current things that's default in UMA is requiring the resource server at the time that it gets a token at runtime to go check with the authorization server about what's in the content of it. But that's not the only option. There can actually be a disconnected way for it to introspect the token all by itself at the cost of latency of the entitlements inside. So I think things like disconnected mode are a natural match for, like I've been looking at the all-scene work, for example, and I think that it would be very friendly to the all-scene model, for one. And so I think that there's a number of things that could be done that would just be, I would say, slight variations on the UMA theme. And I'd love to actually get into that for anybody who's interested to explore those. I've actually got a pile of business cards here. I invite you to connect up with me and discuss those. And I think that's it. And I want to just ask everybody to give Param a huge round of applause for being so awesome. Woo-hoo! Thank you very much. And any other, this is like a 2 minutes, yeah.
Yeah, who's on board with UMA? I mean, companies are going to support it.
So right now, so I'm with ForgeRock. ForgeRock is on board with UMA. A company called Glue, a company called Cloud Identity. I haven't seen CA actually talk about it on the roadmap, but they did sponsor a webinar that we did on UMA in the enterprise.
People like Google, Facebook, Apple.
Those big three have not yet, although Google has a very nice proprietary implementation that's similar. No, I would say it's not in that realm yet. I would look to like API management and identity first, which is, I mean, that may be a little bit, for this kind of conference, it may be unfamiliar players, but.
So my question is, does it still offer enough value without the biggest players on board?
I would say it's the right place to start, but I think that, you know, it's I can't remember if I mentioned the name of the working group, but the Health Relationship Trust Working Group that's about to start profiling OAuth and OpenID Connect and UMA for health data APIs is going to be taking place in the OpenID Foundation. And we have been, so I'm proposed co-chair with Health and Human Services, somebody from Health and Human Services, and we've been working with folks from Google and Microsoft and I don't know, various other folks to get the charter approved. I would love to see them take part in the group, and that would be a good sign. Put it that way. Other questions before we gotta? Yeah. As is Param. Thank you.